Alright, this video is for Euler's method. It looks like it should say Euler, but it is a German name, and so it's Euler's method. I've mentioned Euler before because the E, 2.71 that we use, Euler gave its symbol, which, since it starts with an E, that gives you a hint why that happened. Euler's method is an approximation method that we will use to find an approximate y value. The reason we have to use these approximations sometimes is the same reason we had to use slope fields, which is that not everything is integrable. So some of the things we're going to practice with we could solve on our own, but we're going to practice them with Euler's method anyway. So given dy dx equals 1 over x plus 2, y of 0 equals 1, find an approximation for y of 1. So what we're going to do is we're going to start out with the fact that x naught, the original x, is going to be, let's use a different color here, is going to be 0, and y naught, the original y, is going to be 1. Now we're trying to get to y of 1, which means that the x value is going to be 1. So down here we're trying to get to an x value of 1. And what we're going to do is we're just going to use some really short steps. So usually what they'll do is they'll tell you delta x is 0.5, or sometimes they'll call it h. So for ours we're going to say delta x is 0.5. So x sub 1 would be 0.5 because we started as 0, and if we add 0.5 we get 0.5. And x sub 2 would be 1, which is what we're trying to get to. So this just tells us where we're going to stop. This will make more sense as we do more practice with it. So we start with our x naught and our y naught, and we use our change in x to determine x of 1 and x of 2. Now what we need to do is find the y values that go with this, because when we get the y value that goes with this x value, then we'll have our answer. So the formula for finding the y values is a little bit different. You're going to take the previous y value, which in our case was 1, plus whatever the delta x was, which is 0.5, times the previous slope. So the previous slope, well, our slope is right here. dy dx stands for slope, and it's 1 over x plus 2. So when y naught was 1, x naught was 0. So dy dx is 1 over x plus 2 means 1 over 0 plus 2, because the previous x was 0, which would be 1 over 0 plus 2, which is 2. And so we have the previous y value plus the delta x, the change in x, times the previous slope. So that is actually going to be, what, 1 plus 0.5 times a half is really 0.5 times 0.5, which is 0.25. So y1 is 1.25. Okay? So now to find y2, we're going to take the previous y value, which was 1.25, plus the delta x, which is 0.5, times the slope using the previous x and y values. So if we use 1 over x plus 2, which is our slope up here, and we plug in an x value of 0.5, that's 1 over 0.5 plus 2, so that's 1 over 2.5. So what we have is 1.25 plus 0.5 times 1 over 2.5, which is actually going to be 1.25 plus, if we move the decimal over and decimal over, we get 1/5, and 1/5 is the equivalent of 0.2. So 1.25 plus 0.2 equals 1.45. So our answer, y of 1, is 1.45, and that's an approximation, so I need to put an approximation symbol on there. Okay, so you're going to need your calculator for many of these things because the decimals just get to be a little bit hairy. So let's see, officially, here's what your formula is. When you're trying to find the next x, you take the previous x plus the delta x. When you're trying to find the next y, you take the previous y plus the delta x times the y prime of whatever that previous y was. Okay, so this slope right here is the slope at the previous x and y. So if we have y1, then this would be the slope at x naught or x0 and y0. Okay, so let's look at another example. We have the point 2, 0, so this is going to be x naught and y naught. Our slope, dy dx, is 4x plus y, and we're trying to approximate y of 3. Now again, I'm going to use my delta x to be 0.5. Keep in mind, most of the time, problems will tell you what your delta x is going to be. And I'm using 0.5 because it's short and easy. We could use 0.25, and I promise you that the numbers would get a lot uglier. I also do not have a calculator with me, so if it starts to get yucky, we're going to be in some trouble. Okay, so x naught is 2 because that's the original 2, and y naught is 0 because that's the original y. So if we have a delta x of 0.5, then we take 2 plus 0.5 gives us 2.5. So x1 is 2.5. So x2 would be the previous x, which is 2.5, plus the delta x, which is 0.5. So 2.5 plus 0.5 is 3. And that's what we're trying to approximate, is y of 3. So that tells me that's where we're going to stop. And now all we have to do is come over here and find our y sub 1 and our y sub 2. And then we have our answer. So y sub 1 is going to be the previous y value, which was 0, plus the delta x, which is 0.5, times the previous slope. So our slope formula is 4x plus y. So we have 2 and 0 are our previous values. So if we do 4 times 2 plus 0, we get 8. So 4 times 2 is 8, plus 0 is 8. So we have basically 0 plus half of 8, which is 4. So y sub 1 is 4. So to find y sub 2, we're going to take the previous y value, which now is 4, plus 0.5, because that's our delta x, times the previous slope. So the previous slope is going to use 2.5 and 4 in its approximation. So 4 times 2.5 plus 4. So 4 times 2.5 is going to be 10, and 10 plus 4 is going to be 14. So what we have here is 4 plus half of 14, which is 7. So 4 plus 7 is 11. So we know that y of 3 is going to be approximately 11. Okay? That's it. That's how you find Euler's method. I have a worksheet for you that you will get in class tomorrow, or today if you're seeing this video today.